Hello everyone, this is Dr. Suman, Associate Professor from the Department of Civil Engineering, AGIT Mangalore. Today I will be dealing with the numericals on the concept of centroid. We have already seen the derivations of the centroid for some of the simple geometrical figures, and we'll move on to the problem how to apply those formulas in solving a bigger ensemble. Usually they will not give you a very simple rectangle or something to solve. It is an combination of many rectangles, triangles or square or whatever geometric shapes we have seen. It's a combination of that. You are supposed to find out the x bar and y bar for the entire figure. So let us take the first problem, that is find the centroid of the given figure. This is basically a T section we call. So it is a combination of two rectangles. We do not have a direct formula to find the area of this. What we will do is, and even the centroid to find. We know the formula for the simple rectangles. So what I will do, I will split up this T section into one rectangle here, another rectangle here. So I'll split it here. So it looks something like this. We know the formula to find the centroid of the rectangle separately. So we will find out the centroid separately for each rectangle, multiply it with the area of each rectangle and find out what is the moment of area. Then we will calculate the summation of the moment of area of each component, and using this formula what we have seen in the previous video, x bar we find out for the entire figure. So summing up all the moments of each figure along this one x, and then summation of the entire area, you will get the x bar, and similarly you will get the y bar. Now from where, with reference to what I have to consider the x bar and y bar? You have to take the reference axis. Here it is given the reference axis OX and OY. But if it is not given, you can take at the extreme corners touching the figure the reference axis OX and OY. From here you are supposed to find out the distance of x for each of the rectangle. So here this y axis and this x axis is the centroidal axis which is passing through the middle of the figure. In this case, you know that this T section, if I fold this lamina along the y axis, it is equal. The left portion and the right portion will coincide. So you know that it is symmetrical about the y axis. So the x bar from this y axis, reference y axis, is constant throughout. So this x bar is constant throughout. So I can directly take as whole distance is 120. This divided by 2, you will get 60 mm. So doing all this process also, you will get x bar as 60 mm. But since it is symmetrical about y axis, I can directly find out the entire figure is 120 divided by 2 is 60. So x bar is 60 mm. I can directly decide if the figure is symmetrical about y axis. Okay, but the symmetry doesn't exist in case of the x axis. If I draw the x axis here and fold this lamina, it is not symmetrical about the x axis. So there exists some y bar. What is that y bar you are supposed to find out? So for this, let us start taking each rectangle. Take the first rectangle. Okay, that is rectangle 1. Find out the area of this. 120 into 10 is 1200. Take the rectangle 2. 60 is the depth, 10 is the width. So it is 10 into 60, 600. Okay, this is the area of two rectangles. Now take the first rectangle, and the CG will lie, center of gravity will lie here in between, here, somewhere here. So what is this distance from here to here? For a rectangle, we know it is b by 2. X bar distance is measured from with respect to y axis. So it is from this till here. Whole is 120 divided by 2. So x1 is 60 mm you will get. So please enter that value in this. Centroidal distance from y axis, that is x. In the main formula, that is x1, x2, x3, I told you in that elemental strip in the previous video. Yeah, that is what is 60. distance of CG of the rectangle 1 from the y-axis. Okay. So, go to the second figure. This rectangle, this point from the y-axis. So, G2 of this rectangle. You know the total distance is 120. 120 divided by 2. So, again here it is 60. Okay. Because this line is at a distance of 60 from this point. Whole is 120 divided by 2, 60. So, this is also 60. Next, move on to the centroidal distance from x-axis, that is y distance. Centroidal distance from the x-axis, that is the y distance of each figure. Okay. So, first let us solve for rectangle 1. This point, you have to reach this point from this axis. Okay. What is the distance from this axis? First, you have to cover 60 millimeter. After that, d by 2. 10 is a 10 by 2. So, it is 60. Okay. See here, 60 mm plus 10. This is 10 divided by 2. Here the G1 lies of the rectangle 1. So, this is your Y1. So, write it in the place of Y1. Okay. Now, second rectangle is this one. Distance from this axis to this point is, whole depth is 60 divided by 2 is 60 by 2. You are supposed to reach this point, right? So, G2 lies here. Whole is 60 divided by 2 is 30 mm. Okay. So, this is nothing but 30. So, the next step is simple, that is you are supposed to find out the moment of area for x and moment of area for the y, that is area into x. 1200 into 60 is 72,000, 600 into 60 36,000. Okay. Likewise, area into y, that is 1200 into 65 is 78,000, 600 into 30 is 18,000. Sum up these values, you will get summation of AX 108,000, summation of AY 96,000. Add up these areas, summation A, we want the total area, right? That is 1200 plus 800, 600, 1800. So, you wouldn't have been directly, you wouldn't have been able to calculate the area of this entire T section. 1800. So, we have split it and found out. Okay. Now, we have our formulas from the moments which we found out, that is x bar is equal to summation AX divided by A. Put the respective values, summation AX divided by summation A, summation AY divided by summation A in this formula, and you will get the x bar for the entire figure, y bar for the entire figure. So, now you understood what is this x bar. X bar is for the entire figure, y bar is for the entire figure. So, we have solved the centroid of this T section. Okay. So, moving on to the next problem, we have the next problem. Find the centroid of the given figure. So, if you look into this figure, this is basically a I section which has 3 rectangles in it. So, I will split it into 3 rectangles and then solve it. So, if you look at this figure, like in the previous case, the y axis, centroidal axis is at a distance of x bar from the reference axis, reference y axis, that is throughout. It is symmetrical about the y axis. If I fold this figure about this y axis, it is symmetrical. Left portion is similar to that of the right portion. So, it is symmetrical. So, x bar I can directly write it as 80 divided by 2, which is 40 mm. So, it is x bar is equal to 80 divided by 2 is equal to 40 mm. As in the figure, it is symmetrical about the y-axis. So no need of working out for x bar. In the previous problem also it was a similar case, but still we have worked out to confirm whether it both are same. Okay. Now let us move on to each rectangle component. So there are three rectangles, as I said. This is the 1, name it as 1, name it as 2, name it as 3. So all three are rectangles. So let us go to the first one. Area of the first one is 80 into 10. Second one is 40 into 10. Third one is 25 into 24. Okay. So 10 into 80, 25 into 24. Okay, this is the area of all three rectangles. Now I am supposed to find out x bar, I know. So I need only y distance from the x axis, because I have to calculate what is y bar. What is the y bar formula? Summation of ay divided by summation a. So I need to find out what is this summation ay and summation a. In order to find out summation ay, I need to know what is y. For each rectangle, I need to know what is the y distance from the x axis. So this is your reference x axis. From here, what is the centroid CG of each rectangle I need to know. Let us begin from the first rectangle. So what are the distances? If I have to reach this point, CG is somewhere here for this rectangle. To reach this point, I need to add 24 plus 40 plus 10 by 2. That is 24 plus 40 plus 10 by 2, which is 69. Okay. Moving on to second rectangle. Up to here it is second rectangle. The CG will lie somewhere over here. So from the x axis it is 24 plus 40 by 2. This whole is 40 by 2, because CG, that is y for rectangle, is d by 2, correct? So I'll get it as 24 plus 40 by 2, that is 44. The last rectangle, that is this one, 24 by 2. 24 by 2. It's here. Figures are given in the next page for your reference. Okay. Next, just multiply this a into y. This is a into y here. 800 into 69, you will get this value. 400 into 44, 17,600. This area into y distance, you will get 7,200. Sum up everything. You will get summation ay, moment of area, sum of moment of area of all the rectangles. So that divided by the actual area, entire area, will give you the y bar distance. So x bar and y bar is found out. That is all they have asked in this problem. Okay. So this is how you measure the distances from x and y axis, reference axis, for each rectangle. Next we'll move on to the next problem. Find the centroid of the given figure. So this is all they have given you, and you are supposed to find out what is the x bar and y bar for this particular section. This is called as the C section. If you look about the symmetry of this figure, in the previous problem we saw it was symmetrical about the y-axis. If you look into this problem, it is not symmetrical about any axis, correct? If I fold along this x-axis, or if I fold this figure along the y-axis, nowhere it is symmetrical. Left portion and right portion doesn't match. So in this case, both x bar and y bar you have to find out individually. However, only rectangles are involved in this particular section. So let us divide this entire C section into three rectangles. That is one rectangle, second rectangle, and the third rectangle. Let us consider the first rectangle. Find out the area for the first rectangle, that is 60 into 12. 60 into 12. Next, x distance from the y-axis. Okay. So x distance from y-axis for this rectangle is, entire thing is 60 divided by 2, you will get 30. Okay. Next rectangle, second rectangle, area is 10 into, this whole is 128, 10 into 128, 1280. And x distance from the y-axis. From this point, CG of this rectangle somewhere in midway between it will lie, right? So what is this distance? Whole distance is 10 divided by 2 is 5. Third rectangle, area is 75 into 10, 750. The center of gravity CG will be lying over here somewhere. So this whole is 75 divided by 2, you will get it as 37.5. Okay, so now we have found out the x distances for each of the rectangle. Find out the y distances for each of the rectangle from x axis as reference. Okay, so why they have plotted this y and x axis outside the section? Because you do not know where the CG will be lying for the entire section. So they have plotted it here. Let us see what is this x bar and y bar distance, where it will lie we can see after finding out the x bar and y bar. So now y distances with respect to x axis. From here, from this x axis, this point CG of this rectangle where it is lying we need to find out. So you have to sum up all these distances. That is, for the first rectangle it is 10 plus 128 plus 12 by 2, it is 144. Next one, 10 plus 128 by 2, this point you get 74. The next value for this, the y distance is at 10 divided by 2, so it is 5. Okay, so you have found out x, you have found out y. Now find out a into x. That is a into x. Multiply this, you will get 21,600. 1280 into 5, 6,400. 750 into 37.5, you will get 28,125. Next you go on to ay. A into y. 720 into 144 gives you 103,680. 1280 into y gives you 94,720. 750 into 5, 3,750. So multiplying a into y, a into x. Sum up this everything. Total is so much. Sum up this one, you will get total so much. Now we have our formula. X bar is equal to summation ax divided by summation a. Add up all the areas, you will get 2,750. Divide by the area here, 56,125 divided by 2,750. Likewise, 202 150 divided by 2750, you will get this. So you found out x bar and y bar. Okay. So from the reference axis, x bar is lying somewhere outside, right? This is maximum, this width is 10 mm, but what you have found is 20.409. So your x bar is lying somewhere here, 20.409 from the y axis. And where is the y bar lying? At 73.5 millimeter. 73.5 millimeter means this is 10, this plus 60 somewhere, 63. So somewhere here it will be lying. So that is why it is represented. So initially we will not know where it will be lying. We are assuming that this is the centroidal axis, and then we will find out what is the exact distance. So this is how we find out the x bar and the y bar. This is the last step actually. Just to accommodate everything in the same page, I have written the answers at the top. First you are supposed to solve this. After getting this, you will arrive at this. Okay. So we'll move on to the next problem. So the next problem is again to find the centroid of the given figure. So you see here, this is a combination of a triangle and a quarter circle. So you need to remember the centroidal formula for triangle, for quarter circle, circle, all the important geometrical shapes for which we have derived the x bar, y bar. Okay. Now we'll start with this. See, if this type of figure is given, easiest way is to split it into a triangle and the quarter circle. Okay. There are other ways to solve that, that is to remove cutting portion. We remove the cut out and then we'll solve that. We'll solve next set of problems. In this we'll only do the adding up things. Okay. So I will take this as triangle and this as quarter circle. First one is triangle. I've taken. Find out the area of this triangle. Half into base into height. Height is not given. How will you find out? This is a quarter circle. Quarter circle radius is 80 mm. So if this is 80 mm, this side also it is 80 mm. So half into 80 into 80. 3200. For this triangle, the CG will be lying somewhere here. When we were solving the support reactions also, I have introduced where the CG of the triangle lies. It lies at a distance of 2/3 from the 2/3 of base from the apex point. Okay, so it is at a distance of 2/3 R or 2/3 base from this point, correct? And from this side it is 1/3 base, 1/3 of 80. Okay, so you should remember that. From this side also, this is lying at the 2/3 of 80, and from this side it is lying at 1/3 of 80. Okay, so now this x distance, x is measured from the y axis, so the x distance is 2/3 of 80, 53.33. okay. Then y distance, this point is at a distance of 1/3 of 80. Okay. Now a into x, that is 3200 into 53.33, you will get so much. Area into y, this value into this value, you will get this much. Okay, that is about the triangle. Next, going on to the quarter circle. Quarter circle, you know area as pi r square by 4. Okay, for semicircle it is pi r square by 2. Okay, so pi r square by 4. What is r? R is 80. So find out what is the area of the quarter circle, the figure 2. Now I am supposed to find out what is the x and y distance for this quarter circle. So x distance is with respect to y axis. I have to reach up to this point, correct? We have already solved what is the x bar for a quarter circle. What is the x bar for a quarter circle? It is 4r by 3 pi. 4r by 3 pi for a quarter circle. So what is this distance? This is 80. 80 plus, if I have to reach this point, it is 4r by 3 pi. So it is 80 plus 4r. R is 80 by 3 pi. Simplify this, you will get 113.9. Okay. Next, y distance. Y distance is measured from the x axis. This y distance, at what distance it is? We have already found out for a quarter circle, y bar is 4r by 3 pi. So it is y bar is 4r by 3 pi. So r is 80, substitute here 4r by 3 pi, simplifying 33.9. Now multiply a into x, a into y. The respective values are this. Sum up all the moment areas and you will get this much. Here also sum up this. Substitute in our basic equation of x bar and y bar. You will get 90.373 and y bar as 31.119. Okay. So all you need to remember is for each shape what is the x bar formula and what is the y bar formula, and carefully see where is the figure placed from the respective y axis and x axis, and that respective x values and y values you have to fill in the tabular column. If you do systematically, then you will not go wrong, and any one small mistake of adding this 80 mm if you leave, or adding this CG you forget, then the whole answer will go for a toss. Okay, so in this way, even the irregular shapes, you don't know what shape it is, you don't have the name for this shape. It may look like a sector but it isn't, so you can directly find out what is the x bar and y bar by splitting it into small components. Okay. So now let us move on to the next problem. See here, there is a combination of many more things. That is, one is a semicircle is there, one more rectangle or square. How do I find out whether it is a rectangle or square? This is a semicircle. They have given you the radius of 2.25. How radius? This distance is given as 2.25. So parallel to this distance is 2.25. So this is also 2.25, this is also 2.25. So this becomes 4.5, correct? So they have not given, but you have to calculate it. This becomes 4.5. 4.5 into 6 is nothing but a rectangle. Okay, so I consider this as a rectangle. So the first component, it's not mentioned here, but remember, anything you can take it as first, second or third. That is not an issue as long as the distances you are writing properly. So I take this rectangle component as the component 1. Then here one more triangle as component 2 and this semicircle as the component 3. Please do it systematically in the similar way by marking the tabular column and marking the respective distances, because there's a high chance of going wrong. Okay. So now you notice one thing. This is the reference y-axis and x-axis given. Semicircle is on the other side of the y-axis. Okay. On the other side of the y-axis, not on this positive first quadrant. It is lying in the second quadrant. Okay. So the distance of x bar will be on this side, that is, it will be minus. Okay, that one thing you have to take care when you come for the semicircle. Other two are lying in the positive x and y quadrant, so no other minus terms coming into picture. Okay, now we'll move on to each component. The first one is the rectangle. Find out the area of the rectangle. 4.5 into 6, which is equal to 27 for this rectangle. Next, go to the x distance with respect to the y axis. What is the x distance? You know, for a rectangle, the CG will lie here, which is, this distance is what? 6. 6 divided by 2 is nothing but 3. Y distance, at this point it is lying. It is at a distance with respect to x-axis, the y distance. This whole is 4.5 divided by 2. You will get the y distance for this rectangle, that is 2.25. Next step is area into x, area into y. Substitute the respective values and find out ax, ay. Now move on to the triangle. This is our triangle. Half into base into height 4.5. Half into 3 into 4.5. You get 6.75 is the area of the triangle. Next, find out the x distance of the CG. The CG of the triangle lies at a distance of 2/3 from this point, 1/3 from this, 1/3 of the base from this point, 2/3 of the base from this point, 1/3 of the base from this point. Okay. So here is the CG line. Find out the area of the triangle, then find out the x distance with respect to the y axis. What is the x distance? Up to this point you have to measure. What is this? 6. 6 plus 1/3 of 3. 6 plus 1/3 of 3 will get 7. Okay. Y distance with respect to, for the triangle, with respect to x axis. From here till here, what is the distance? It is 1/3 of this distance, correct? This point is lying here, so it is from this side, it is 1/3 of this 4.5. 1/3 of 4.5 is 1.5. Okay, so that is about the triangle. Just multiply this area into x, you will get 47.25. Area into y, you get 101.25 for the triangle. Next, move on to our third figure, that is the semicircle. Okay, semicircle, area of the semicircle, you know that it is pi r square by 2. Pi r square by 2. Substitute the r value. R value is 2.25. Radius, you will get 7.95 as the area of the semicircle. Next, you are supposed to find out the x value and the y value. Y value, will be along this. Okay, so it is 4.5 divided by 2 is the y value. X value is in the negative direction, that is x minus 4r by 3 pi. You will get it as r is 2.25, 3 divided by 3 pi minus 0.955. If you are getting the doubt in the semicircular values, please go back to the first slide and look. I have plotted a tabular column and I have written if semicircle is lying in which quadrant, what is the x bar and y bar. Please look into it and keep it in your mind when you solve the problems. Okay, and look into the derivation of the semicircle as well, so it will be more clear for you. So as of now, this x bar is lying in the negative x direction, so I have taken as the negative sign here. Next, we finished y, that is d by 2. Here it is 4.5 divided by 2, that is 2.25. Okay, then a into x, a into y, respective values. Here when you are summing it up, 81 plus 47.25 minus 7.594. So here the minus sign will be present here. When you are summing up, just subtract this value and get the net value 120.65. Okay, here summing up all the three, you will get 88.765. And we know the formula, x bar is summation ax by summation a. Total area is here. Sum up all these three areas. There is no negative sign for the area. Okay, it's only for x bar. Here don't put negative sign for area. It's only for x bar. So you will get the, substituting the respective values in this equation, you will get x bar and y bar. So for the entire figure, this is the x bar and y bar with respect to your reference axis. Okay. So we'll move on to the next problem. So this is a bigger ensemble which consists of many such components. That is, this figure is given. They have not told you, they will not tell you where to split this figure. It is you who have to decide where you have to put the dotted lines, so that it becomes easy for you. Somebody else may solve it in a different way. Okay. So means, see, somebody can put it as a small square here, one more square here. For his convenience, he can divide the entire figure into number of small figures and he can solve. So it is left up to you how you will solve it. So let us divide this. This is basically a dam section. Okay, usually this is the upstream side where the water is stored, and this is the downstream side, if you can visualize it. So this is a cross section of a dam. Okay. Now what I have done is, here this upstream side I have taken it as a triangle. Here one more rectangle. Then split this part as a triangle and one more rectangle. So 4 components basically. Triangle 1. See, please write which is 1, 2, 3, 4 and respective thing you please fill in here. You don't be in a hurry to just finish it off. You have to do it right. That is more important. Okay. So triangle 1, and all these formulas are very important to be written in your answer paper, because it means a lot. There is a lot of meaning for each of the thing. Okay, and fill in the tabular column nicely and properly. Okay, so first triangle, you take this. What is the area of the triangle? Half into base into height. They have given you the height here, 5 plus 1. Up to here it is 6. So it is half into base 2 into height 6 for the first triangle. Okay. Then the x distance from the y axis. You know, for a triangle, from the apex side it is 2/3 of 2. 2/3 of 2 is nothing but 1.33. From the x axis, y axis, it is 2/3 of 2, that is 1.33. Okay. Y distance from x axis, what is the y distance? 1/3 of the entire height. 1/3 of the entire height is 6 here, 1/3 of 6 is nothing but 2. Okay. Then it is area into x, area into y's respective values you fill in the tabular column. Next move on to the rectangle. Rectangle area is 2 into this whole height. What is the whole height? 1.5 plus 5 plus 1, 8.5, 6.5, 7.5, sorry. 7.5 into 2 is the area. How will you find out the x distance? X distance, the centroid of the rectangle is lying somewhere here in between. So that is nothing but this distance, whole 2 plus half of this distance. This is 2 divided by 2. So 2 plus 2 by 2 is 3. 2 meter plus 1 meter, that is 3 meters. What about the y distance? Y distance is measured from the x-axis. The whole is 7.5 divided by 2, that is 3.75. From here to here it is 3.75 meter. Now multiply area into x, area into y, fill in the respective columns. Okay. Move on to the triangle 3, third triangle, whose area is half into base into height. It's given, base is given as 4 meter. So it is half into 4 into 5. 5 also is given. Half into base into height for the triangle. Find out that. Now find out the x distance and the y distance. X distance from this point is 2 plus 2 plus 1/3 of 4. Correct? 2 plus 2, 2 meter plus 2 meter is 4 meter, and 1/3 of this base from here to here is the triangle's base. So it is 1/3 of 4 is this one, 1.33 plus 4 is 5.33. That is the x distance from the y axis. Y distance from the x axis, that is this component of the triangle, this distance of the triangle is 1 meter plus 1/3 of this distance. This triangle's CG is lying over here. So you have to add 1 plus 1/3 of 5. It becomes 2.67. So multiply this area into x, area into y, ax and y for the triangle. Okay. Last one is this rectangle, the fourth figure. Find out the area of this rectangle. What is the area of this rectangle? 4 plus 1, 5 meter into 1. So it is 5 meter is the area of this rectangle. Next one is the x distance, that is CG is lying over here. What is the x distance from y axis? It is 2 plus 2 plus 4 by 2. No, this is 5, right? 5 by 2, that is 2.5. 4 plus 2.5, which is 6.5 is the x distance of the rectangle 4. And what is the y distance? Y distance is 1 divided by depth of this whole rectangle is 1 meter divided by 2, which is 0.5. Correct? So multiply this area into x, this one, area into y, 2.5. Sum up the moment of area of each component. You will get 138.85 for summation ax, summation ay you will get so much. Find out what is the x bar and y bar for each one. Substitute the respective values here. Sum up all the areas, substitute it here, 36 millimeter meter square. Okay, you will get x bar component and y bar component. Okay, so in this figure everything is lying within the first quadrant x axis, so no negative x and y bar distances. Okay, you need to see whether the triangle is on the other side of the reference axis, not the centroidal axis. Please don't confuse here. And moreover, here that centroidal axis is not marked, correct? So you don't need to get confused regarding that. Okay, so all you are doing is you are finding out the x distance for each component, y distance for each component, and then summing it all and finding for all this you are finding one x bar and y bar for each component. Small x1 y1, x2 y2, x3 y3, you are going on adding it up and finding out the x bar. Likewise for the y bar you are doing. Okay, that is what we are doing in all these problems. So I have given you a simple I section, answers are given here. Please solve this problem and submit in the Google Classroom. And any doubts which you are getting in this concept, please feel free to ask in the Google Classroom or call me up. Okay, and you need practice. The concept is really very easy. If you practice a bit, it will be very interesting and you will definitely solve it right. But all you need is a little bit of practice. So we'll solve some more problems. There are some other type of problems where you have to cut out the portions. So we will solve in the next, I will solve in the next videos. Till then, take care. Thank you. And please submit this solution for this problem by 5 o'clock today. Okay.